China went from buying construction equipment to building machines that now dominate entire industries. A fleet of robots just built 158 kilometers of highway without a single human behind the wheel, guided entirely by artificial intelligence that made hundreds of decisions every minute, while the road came out smoother than what manual crews typically achieve. And that's just one of 8 machines China has quietly built that are already working on projects around the world. What are these machines actually capable of? The first of these machines built 158 kilometers of highway in 2025, doing something that had never happened before in construction history. 10 robotic vehicles lined up on an empty stretch of road and started working with no drivers and no operators and no human hands on any controls. The paver at the center could lay asphalt across a 19-meter width in a single pass, covering the full width of a standard road in one sweep without stopping. And the entire operation was controlled by an AI system that communicated with satellites overhead to maintain centimeter-level accuracy across the entire route. The AI wasn't just steering, but making hundreds of decisions every minute based on real-time conditions. Obstacle detected in the path, and the machine stops and calculates a new route around it. Temperature of the asphalt dropping below optimal, and the system adjusts laying speed to compensate. One machine falling slightly out of sync with the others, and it corrects automatically without human intervention. Surface moisture levels changing, and the compaction pressure adjusts accordingly. The fleet worked like a trained crew, except faster and more consistent and without breaks. And when they finished, the road surface was smoother and more uniform than what manual crews typically achieve, because the machines never got tired and never lost focus and maintained exact specifications for every single meter. Traditional road construction requires skilled operators making judgment calls constantly while managing fatigue and visibility issues and coordination problems across multiple crews. China just proved all of that can be replaced with machines that work better. The second machine was designed for places every other piece of equipment gives up on. The ET-120 looks like a mechanical insect with 4 articulated legs that extend and compress and pivot independently, letting it walk across terrain that stops any wheeled or tracked vehicle, slopes that tip excavators sideways, and the ET-120 walks up without hesitation, ground so soft it swallows ordinary machines, and the ET-120 spreads its weight across 4 legs and keeps moving. People call it the steel mantis, and watching it climb an impossible mountain slope makes the name obvious. It was built for the worst moments. Earthquakes and landslides and wildfires and collapsed buildings where getting equipment to the right place means the difference between rescue and recovery. And in those situations, roads are destroyed and hillsides are unstable, and the terrain is dangerous. The ET-120 reaches those places because its arm accepts interchangeable attachments. So the same machine digs through rubble and lifts collapsed beams and cuts down burning trees and drills through rock and crushes debris without needing different vehicles for each task. And it operates by remote control, keeping the human operator at a safe distance. China has been deploying these in real disaster operations, and a machine that looks like science fiction is already saving lives where no other equipment can reach. A third machine works beneath your feet where nobody can see it. Walk through Beijing where millions of people move through streets with cars and buses and city noise, and 150 meters below a machine the size of a 5-story building grinds through earth and pushes forward through sand and water and soft soil without stopping. Nobody on the surface feels a thing. Jinghua is a tunnel boring machine over 16 meters in diameter, 150 meters long, weighing 4,300 tons, and it drilled over 7 kilometers of tunnel directly beneath Beijing to expand the city's East 6th Ring Road while passing under residential buildings and subway lines and power infrastructure that couldn't be disturbed. The ground below Beijing isn't solid rock, but a shifting mixture of sand and underground water and soft layers that compress when disturbed. Apply too much pressure and the ground sinks, creating sinkholes that could swallow entire buildings. Move too fast and water-soaked layers collapse inward, flooding the tunnel and destabilizing everything above it. Jinghua navigated that perfectly, while control systems monitored ground pressure continuously and adjusted cutter head speed and support pressure in real time. Every millimeter was tracked and corrected if it drifted from the planned path, because at 150 meters depth, There's no room for error and no way to fix mistakes without shutting down major portions of the city above. It worked without a single incident. No cracks above, no sinkholes, no disruption to millions of people overhead. In its best month, it pushed forward over 500 meters while removing thousands of tons of earth and reinforcing the tunnel behind it as it advanced, completing one of the most technically demanding tunneling operations ever attempted in an urban environment. 20 years ago, China bought these machines from Germany and Japan, while paying enormous prices and depending on foreign technology. Today, Chinese-made tunnel boring machines control 70% of the global market, and that shift happened faster than any other major industrial technology transfer in modern history. The fourth machine operates on the open ocean at a scale that's almost impossible to process. A ship the size of 3 football fields, almost 300 meters long, carrying 380 people, and capable of lifting the weight of 8,000 cars in a single lift, without tipping with surgeon-level precision, while waves push against the hull and wind tries to shift the load. The Zhenhua 30 is the most powerful floating crane on the planet, built by Chinese company ZPMC, and it looks less like equipment and more like a floating city with a crane attached. It built the Hong Kong-Zhuhai-Macau Bridge, the longest sea crossing on Earth, at over 55 kilometers, where a section disappears underground through a tunnel on the ocean floor. And building that tunnel underwater required engineering precision that most experts said was impossible with current technology. Those tunnel sections required lifting massive concrete pieces, weighing thousands of tons, and carrying them out to sea, and lowering them to the seabed, where the gap between sections was smaller than the width of your finger. One miscalculation and the tunnel floods, destroying months of work and making the entire bridge project fail. Zhenhua 30 gripped each section with hydraulic clamps and sailed to exact coordinates using GPS positioning accurate to centimeters, and lowered it using sensors and computer controls that adjusted the lift in real time as the ocean moved beneath it, while accounting for current and wind and the weight distribution of the load. The margin of error was measured in millimeters on open water, where conditions change constantly. In 2025, it lifted a 10,000-ton offshore wind platform and placed it in the ocean, treating entire infrastructure pieces the way most cranes treat a steel beam, and no other crane on Earth can match that combination of lifting capacity and precision control. The fifth machine built the network that connects China's cities. China has 48,000 kilometers of high-speed rail track connecting cities that used to be a day's drive apart in under an hour. And 20 years ago, almost none of that existed, while today it's the largest high-speed rail network on Earth, carrying over 2 billion passengers every year. That expansion happened because of the CPG 500, a track-laying system that works like a railway factory on wheels, and changed the economics of building rail networks entirely. Traditional equipment works in stages by placing rail, stopping, repositioning, placing the next section, stopping again, which means every kilometer of track requires dozens of stops and restarts that waste time and create alignment errors. The CPG 500 doesn't stop, but lays rails and places concrete sleepers simultaneously in continuous motion without pausing between placements. In a single shift, it installs 2 kilometers of finished track while working with rail sections up to 500 meters long, a length considered unworkable with older methods because of how difficult it is to transport and handle and align steel rails at that scale. It manages it with just 10 millimeters of error across the entire run, which is tighter tolerance than most human crews achieve with traditional shorter sections. It runs day and night with stops only for scheduled maintenance. Exported to Malaysia and Indonesia and Serbia, where it's building their first high-speed rail networks, and laid the first railway circling the Taklamakan Desert in one of the harshest environments on Earth, where summer temperatures exceed 50 degrees and winter drops below -20. It may not look as dramatic as a spider-legged rescue machine, but in terms of impact on how billions of people move and work and connect across distances, the CPG 500 may matter most of all 8 machines. The sixth machine works underground before anything else can be built. Before any skyscraper rises or bridge gets its first beam or offshore wind platform goes in the ocean, a hole has to be drilled deep enough and strong enough to anchor everything above it. The XCMG rotary drilling rig is the most powerful foundation drill in the world. standing 42 meters tall, like a 14-story building, and weighing 520 tons. Its drill cuts holes 7.5 meters wide, large enough to park several cars inside, and goes 190 meters deep. Picture a 60-story skyscraper flipped upside down and pushed into the ground. It's built foundations for Asia's tallest towers and support piles for sea-crossing bridges and anchor bases for offshore wind farms that must withstand ocean storms for decades. What used to take weeks with conventional equipment, this machine completes in days, while a computer-controlled torque system monitors ground resistance in real time and adjusts drilling force, whether cutting through clay or sand or solid rock. It's been exported to over 80 countries. The modern world sits on top of what this rig makes possible. The seventh machine operates at a scale that stops making sense. The WK-75 is one of the largest electric mining shovels ever built, standing 24 meters tall like a 7-story building and weighing 2,000 tons, while its tracks, the things it moves around on, are taller than a standing adult, and each individual track link weighs more than most people. Its bucket holds 75 cubic meters per bite, the volume of 2 shipping containers scooped and dumped in one movement, and it processes 12,000 tons of rock and earth every hour, which means in a single day it moves more material than a standard excavator moves in a month. In 1 month at a coal mine, it pulls 5 million tons from the ground while running entirely on electricity, with power equal to 50 car engines at full throttle. And that electricity comes from the grid rather than diesel generators, which makes it cleaner and cheaper to operate than any comparable diesel-powered machine. 2 motors drive it, one for the digging arm providing the force needed to bite through compacted rock, and one for the rotation of the upper body allowing it to swing loads weighing hundreds of tons. And together they let it dig and swing and dump in one fluid motion that looks almost graceful for something that size. It was built for China's massive open-pit mines, where existing equipment couldn't handle the extraction scale required, and where the difference between moving 10,000 tons per hour and 12,000 tons per hour translates to millions of dollars in operational efficiency. And watching it work is disorienting because your brain searches for reference points and everything nearby looks small. The 8th machine cuts through what everything else gives up on. Underground right now are gas pipelines keeping homes warm, and power cables keeping hospitals running, and irrigation channels moving water to farmland. And all of that had to be cut into earth through trenches that are long and deep and perfectly straight. Most ground is workable clay or sand that standard trenchers handle easily, but sometimes the ground is granite or dense volcanic rock so hard that conventional equipment hits it and stops. The Tesmec M5 weighs 77 tons, with a cutting chain several meters wide where each link is the size of a brick. That chain wraps around a boom that lowers into ground and drags forward, grinding through rock with relentless force. It operates at 440 horsepower, and its chain spins slower than you'd expect, much slower than a chainsaw, but speed isn't the point. The point is torque, the twisting force at each cutting tooth, and that force is extraordinary. Granite that shatters conventional equipment, the M5 grinds through without slowing, while GPS keeps it cutting at exact depth and direction, automatically adjusting as terrain changes, so the finished trench is perfectly consistent. It barely moves fast enough to notice, but it never stops, leaving clean, straight trenches ready for whatever goes inside. These 8 machines aren't prototypes sitting in labs waiting to be tested, but are already out in the world building and drilling and laying road and rail across some of the most challenging terrain on the planet. The highway that built itself, and the crane that sets tunnel sections on the ocean floor, and the walking excavator saving lives in places no road reaches, all of it is already real and already running and already changing what's possible in construction. 20 years ago, China was buying this technology from other countries while depending entirely on foreign expertise. And today, Chinese companies rank among the top 10 globally, with 13 companies in the top 50 worldwide, where they went from buyer to builder to world leader, in the time most industries take just to develop a single new product line. Every kilometer of track laid and every tunnel bored and every foundation drilled is another piece of infrastructure that didn't require Western technology or Western expertise or Western approval. And the machines doing that work are faster and more precise and more powerful than what came before them, while costing less to operate and maintain. The question isn't whether these machines can compete with what the rest of the world builds anymore. because they're already past that point and setting records that others are trying to match. The question is, what happens when the technology gap keeps growing and these machines become the only option that makes economic sense for projects that need to get built? What do you think? Drop your answer in the comments. If you want to see more videos like this, hit the like button and subscribe. Thanks for watching.